Hi. Today we're going to look at Chapter 3, Complexity Number 1, Versatile Elemental Structure. And what we need to understand or take away from this unit is that all things in nature are made up of substances, and all substances are made up of either elements that make molecules, or molecules that make mixture. And the elements that we're probably most familiar with are things like hydrogen, oxygen, carbon, um, gold, silver. Those are the smallest structure that can be maintained of that substance. There's no chemical or physical action that can be done to those structures that will make them any more simply organized. I guess that's the best way to put it. And so when we have two elements that come together and make a molecule, that is the beginning of our building blocks. And elements that we're familiar with, or molecules we're familiar with, maybe water, for instance. You have H2O, means that there are two hydrogen atoms that are bonded together with the one oxygen atom, and they are sticking together very closely to make the water molecule. Now, there's a couple of things that we need to look at when we talk about why water stays together. Why does that hydrogen and oxygen stick together? Well, in the structure of the atom, we have protons, neutrons, electrons, the atom nucleus, and then that together makes the molecule. And if we're looking at the structure of just an atom, the nucleus of the atom is the center, obviously. The electrons and the protons orbit around the nucleus in the shells of their orbit, and the protons have negative charge, the electrons have positive charges, and then there are neutrons. The neutrons do have, they are neutral, as their name represents, but they do have a benefit because they increase the mass, or the density weight, of an atom. And if an atom is heavier, it can bond tighter. It can heat quicker, it can move faster, and so neutrons do have their usage even though they don't have a charge. So if we've got water, we've got two hydrogen atoms bonding with an oxygen atom. The oxygen atom is larger, and because the oxygen atom is larger and it's heavier, the electrons from the hydrogen atom are actually coming closer to the nucleus of the oxygen than the nucleus of the hydrogen. And because they're all sharing the outer orbit of that element, they're covalently bonded. They're very happy together. But because the oxygen element is larger, and it has more, because it's larger, it's heavier, it has more gravitational pull, those electrons are coming closer to that oxygen nucleus. We have a polar covalent bond. They are being polarized, they're being pulled in by the oxygen. Then we have elements that bond together in an ion bonding. Ionic bonding is a negatively charged bonding, where in the exterior shell or orbit of the compound there is one extra proton, and so it gives a negative charge and holds together because of that extra proton that extra particle of that atom being a proton. It gives it a negative charge, and it will respond and bond quicker and stronger to other molecules that have a positive charge, or a covalent bond where there is a sharing of that orbit. Then, as we look at this bonding, we think about the complexity of the atom, the proton, the neutron, the electrons, the atom nucleus, and their orbits and their shells. We can actually compare that to our solar system. And before, when I was discussing with you the whole idea of the plan and the design and the pattern, this is just one more evidence that there is a design in all of creation, that things are put together in certain ways. There are patterns that work. There are patterns for repetition. There are patterns for predictability that we see in all areas in nature.